Happy Monday, everyone, April 12th. Today, we're going to be able to identify the parts of a 3D shape. I can draw and identify nets of 3D shapes. Again, as the sub is here, make sure you continue to do what is expected of yourself. Ask questions. If they're not able to answer the question, please write them down, and I will answer them when I return. You should have already completed Math Olympics event number 9 today. Then what we're going to do today in class is lesson 14-1 and 14-2, which is talking about and understanding 3D shapes. Your homework tonight is Math Excel 14-1 and 14-2 3D shapes. All right, in lesson 14-1, analyzing 3D figures. A three-dimensional figure is a figure that does not lie in a plane. So you should be writing three-dimensional. This is not going to be very good handwriting. I apologize. M-E-N. I think you get the point. Figure. Okay, so a three-dimensional figure, if you just want to write 3D, that also works. All right, let's identify the different parts of a 3D figure. 3D figure has faces. So the faces of a 3D figure are these. A face of a 3D figure is the flat surface shaped like a polygon. So it's the 2D shape on the three-dimensional object. Next, we have the edge of a 3D figure. An edge of a 3D figure is a segment formed by the intersection of two faces. So here, this front one is a face, this side one is a face. The intersection of them create an edge. On your guided notes, next to edge, I would also write line segments. They are the line segments. Here, 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 all of them. Lastly, we have a vertex of a 3D figure. All right, a vertex of a 3D figure is a point where three or more edges meet. So edge, edge, and edge meet to create a vertex. Vertex is a singular word. That's some language arts information for you. The plural for multiple vertexes would be vertices. So if you see vertices, that would be a vertex in plural form. All right, the next thing I want you to do on your guided notes is to decide where each statement is true or false. Go ahead and take this time to solve for those. The figure is a three-dimensional figure. That is true. It has 3 dimensions. The figure has 3 faces. That is false. It has 1 on the bottom, 2 up top, 3 in front, 4 in the back, 5 on the side, 6 on the other side. The faces are triangles. That would be false as well. They are rectangles. The figure has 12 edges. That is true. You can count them in the back. 1, 2, 3, 4. In the middle, 5, 6, 7, 8. In the front, 9, 10, 11, 12. And the figure has 6 vertices. Remember, vertices is a vertex in plural form. That is false. There are 1, 2, 3, 4, 5, 6, 7, and 8 vertices. Moving on to part 2 in the guided notes. A prism is a 3-dimensional figure with 2 parallel polygonal faces that are the same size and shape. Let's talk about that. 2 parallel polygonal faces. Our face is here at the bottom, where it's sitting on a table, let's say. That is a polygon, and it's a face. It has a parallel one up above it. An example would be a tissue box. A tissue box sitting on a desk, that bottom part is a polygonal face. The top, where you take your tissue out, is another polygonal face, and they are parallel to each other. So your base, a base of a prism is one of a pair of parallel polygonal faces that are the same size and shape. So the top and bottom in this case are our base. The height of a prism is the length of a perpendicular segment that joins the bases. And you should be filling these out as we go. The height connects our 2 bases with a perpendicular segment. Perpendicular segment means it creates a 90-degree angle. The next part in your guided notes is the lateral face of a prism is the face that joins the bases to the prism. So again, a side length of a lateral face would be your height. You're just going along with the guided notes. And lastly, in a right prism, all lateral faces are rectangles. So the last one there before the letters on the front side is a right prism. All right, the last part of 4.1 on the front side is an example. So how many bases does the prism have? Here is our prism. How many bases does it have? It's going to have 2 bases. It has this front face and it has the back face. What shape does the base of the prism have? The base is an 8-sided shape, so it is an octagon. Then name the prism. We name the prism from the shape of its base. So the base is an octagon, so it's called a octagonal prism. Octagonal prism. the height of the prism. The height of the prism is going to be 12 centimeters. From the base to the other base is 12 centimeters. Oh, I'm sorry, this should go up here. Octagonal prism should be C. How many lateral faces does the prism have? Should be 8. 1, 2, 3, 4, 5, 6, 7, and 8. So A should be 2, B is an octagon, C is octagonal prism, D is 8, and E is 12. In part 3, on the back side of guided notes 4-1, analyzing 3D figures. Part 3 says pyramid, which is what you are going to type in your guided notes or write in. A pyramid is a 3-dimensional figure with a base that is a polygon and triangular faces that meet at a vertex. So your first one on the back side is a pyramid. We have the base. Base should be your next answer. Of a pyramid is a polygonal face that does not connect to the vertex. So here is your base at the bottom, the red. It does not connect to your vertex. They do not touch. The height, well, let's go back to, you name a pyramid from the shape of its bases. The base is a square, and this is a pyramid, so it's a square pyramid. If this was a rectangle, it would be called rectangular pyramid. If it was a triangle, it would be a triangular pyramid. If it was an octagon, octagonal pyramid, hexagonal pyramid. Those are all examples. Okay, next, under that, it says the height of a pyramid is the length of the segment perpendicular to the base that joins the vertex of the base. So again, here's our base. It connects, this line segment connects to the vertex, and it creates the right angle. Moving on. Under the height, we have a lateral face. Here's lateral. Of a pyramid is a triangular face that joins the base to the vertex. Here is a lateral face. Connects the base to the vertex. It is a face. There are 1, 2, 3, 4 faces in this problem. Next, then we'll go over an example. A right pyramid. The segment that represents the height intersects the base at its center. So right pyramid, the segment that represents the height intersects the base and its center. So it's going to come straight down and meet in the middle of this square. Here's an example.
6 sides. What will they think of next?
What will they think of next?
King Tut has another thing coming if he thinks this will catch on. 4 sides is fine. 6 is just plain showing off.
Ridiculous.
Ridiculous.
All right, filling in the last part of 4-1 guided notes. How many bases does the pyramid have? Remember, the base is a pyramid of a polygon face that does not connect to the vertex. So we do not connect to the vertex, which is the top here. That would be 1. It has 1 base. What shape are the base or bases? We have a 1, 2, 3, 4, 5, 6-sided shape. So that is a hexagon. Let's name it. The name of this pyramid would be called a hexagonal. You name it by its base. It is a pyramid. How many lateral faces does the pyramid have? Lateral faces are what connect the line segment of the base to the vertex. Here is a lateral face. It has 1, 2, 3, 4, 5, and 6 lateral faces. The height of the pyramid connects the base to the vertex at a 90-degree angle, meaning it'd be 9 meters. That is it for guided notes 4.1. You can go ahead and get out your 4-2. In lesson 14-2, the key concept, it says a net, which is going to be your answer there. A net is a 2-dimensional pattern that you can fold to form a 3D figure. A net of a figure shows all of the surfaces of the figure in one view. In other terms, it is a 3D shape flattened. Another way to think about it is if we take a box from, let's say, Amazon, and we flatten it out to create a 2D shape, that would be your net. Or you can look at a box of popcorn. We can decompose it, flatten it out to a 2D shape. That is going to be your net. What I'd like you to do for this question is, I'd like to see if you can draw the net that goes with the 3D shapes. If you look at all of these, we have 2 prisms and 2 pyramids. I'll start with this one. This is a prism. This one here is also a prism. These 2 would be pyramids. All right. Now let's align them together. The juice one is going to be this right here. It's all rectangles. So I label this 1, 2, 3, 4. This one's 4. And the other here, prism, would be a triangular prism. So this one is a 1. This pyramid here has a base that is a triangle. This one aligns with that. and this is a rectangular pyramid. The size of those triangles are different. So please draw those nets below the 3D shapes. In part 2 of lesson 4.2 notes, it says if the base of a prism or pyramid is a regular polygon, so that's what you're going to type in, you use the word regular to name the prism or pyramid. For example, the prism shown is a regular pentagonal prism. This is pentagonal because it has 1, 2, 3, 4, 5-sided shape as its base. And it is regular because these side lengths are equal to each other. And the angles are equal to each other. So we know something is regular when, or regular means all sides are equal and all angles are equal measure. What kind of three-dimensional figure do you think is here from the net? Remember, it has to have two bases. So 1, 2. There's an identifies as two bases. It is a 1, 2, 3, 4, 5, 6 sided shape. So that would be a regular hexagonal prism. Should be typing. All right, regular hexagonal prism. All right, and the last part here, part 3. See if you can draw the net of a triangular prism. Okay, here is the net of this triangular prism. Remember, our triangles are our two bases. If you want some help with how I did this, this is the top base up here. This is the bottom base. This is the back face that we see here. That's a lateral face. This is the right face. This is the left face. Left face, right face. All right, that is it for lesson 4.1 and 4.2. You can now attempt your homework. Have a wonderful rest of your day.